So we're given the graph of g of x here. We want to sketch and label its image after a vertical compression of factor of 1/3, then a translation of 2 units up. Vertical, is that going to affect x or y? Y. So this means I'm going to multiply y by 1/3 and then up 2. So if we took all the points that we have, and we actually want to list them, we have 4, 6, 1, 0, -2, -3, and -5, 3. Those are the 4 points that we have listed. I would suggest doing this in 2 steps. First, we'll look at what happens when we multiply y by 1/3, and then we'll look at what happens when we go up 2. The reason I would do this in 2 steps is because you're affecting y twice. Y by 1/3 affects the y coordinates, and then up 2 affects the y coordinates again. You might be able to do it all in 1 step, and that's great, but your chances of a mental math error by doing it in your head and writing 1 step increase, so this way I would suggest doing it in 2. So y by 1/3, you can just go through your y values and multiply them all by 1/3. It's nice that they were all nice values. We don't have any fractions. And then move them up 2. And now we can go and label those points. So we're going to have 4, 4, 1, 2, -2, 1, and -5, 3. Join them with a straight line. And ask yourself, does it look like it's been compressed vertically by 1/3 and then moved up 2? Yeah. So this is one with only vertical things. If we wanted to write an equation for this, vertical stuff happens outside of the function. So when we write this equation and label it, we're going to get y equals 1/3 on the outside of our function and the plus 2 on the outside of our function as well. Now something special happens when you do horizontal stretches and compressions and horizontal translations. So we're going to look at the example that was pre-done for us as well. And just work through it and see what happens. So again, if I had this graph with those same points, I can label those points again. Are these, is it the same graph? No. 4, 2, 2, 5, 0, -2, and -4, 3. So I have those 4 points. This time we want to look after a horizontal compression by a factor of 1/2. So that's horizontal. This means that we're going to multiply our x values by 1/2, and then 3 to the left after that. Again, since both of those affect x, we'll do it in 2 steps. First, we'll do the x by 1/2, then we'll go left 3 and look at where it ends up. So x by 1/2, 2, 1, 5, 0, -2, and -2, 3. And finally left 3, -1, 2, -2, 5, -3, -2, and negative 5 comma 3. So we can label each of those points negative 1 comma 2, negative 2 comma 5, negative 3, negative 2, and negative 5 comma 3. And join them up. Now, this part of drawing it is nothing different than the equation before. But the hard part and the special note that we're going to write down for any time that we have a horizontal stretch compression with a horizontal translation, when we go to write this equation, everything is going to happen inside the function. And we looked at this a little bit yesterday. How do we write this? Multiplying by 1/2 is going to be a 2. The translation 3 to the left is going to be a plus 3, and you will be tempted to do this. Because that has the 1/2, and it has the 3 to the left. This won't be right because this one will actually only move it 1.5. And what we talked about the other day about factoring out that value, the way that you have to write it is with an extra set of brackets. The horizontal stretch compression always is factored out. So you'll have an extra set of brackets. And if you look back to that original question that we did right at the beginning with the absolute value, it is factored out. So at the bottom of your page, you've got space there at the bottom. You can write a special note. So whenever you have a horizontal stretch / compression, or even just a simple reflection with a horizontal translation, you must write it in factored form. Yes. It means that if you had, let's do an example with one of our parent graphs. Let's say x cubed. If you had the following. Let's say, how would I, let's write it like this. If you had this, everything is inside the cubed. On first look, it looks like we're going to multiply x by 1/3 and shift it 6 to the left, but this isn't in factored form. And so you would have to change this to look like this. You can either use larger brackets or square brackets and round brackets. So would you agree, first of all, that these two are equal as far as equation goes?
Yes.
Okay? But it's only the second one.
Please have Cody Gibbs and Caitlin Friesen in grade 10, please. Grade 10, Caitlin Friesen and Cody Gibbs, please report to the office.
It's only the second one that tells us how that graph is going to be transformed. We're going to multiply x by 1/3, and then we're going to go left 2. Okay, so there's some more examples, and the questions you can do are 4, 5, and 6.